Hello everyone, I'm Tarun Project from CSE graduating in Sri Venkateswara College of Engineering. In this presentation, we will see about the Waterfall Model. The Waterfall Model is a linear and sequential project management methodology that follows a rigid and structured approach. It is widely recognized for its simplicity and straightforward nature, making it a popular choice for many software development projects. The model's name is derived from its sequential nature, where each phase of development cascades down like a waterfall, flowing from one stage to the next. In this slide, we will see about the phases of waterfall model. The first phase is requirements gathering. This initial phase involves a thorough understanding of the client's needs and expectations. Requirements are meticulously documented to ensure a clear roadmap for the project. The next phase is design. The design phase translates the generated requirements into a detailed blueprint. This includes system architecture, data structures, user interface design, and other technical specifications. The next phase is implementation. In this phase, the actual coding and development of the software solution takes place. Developers follow the defined design and coding standards to build the software system. The next phase is testing. After implementation, the software undergoes rigorous testing to ensure it meets the specified requirements and performs flawlessly. Various types of testing, such as unit testing, integration testing, and system testing, are conducted. The next phase is deployments. Once the software is deemed ready, it is deployed to the target environment. In this slide, we'll see about the requirements gathering. Understanding needs. The process starts with a thorough understanding of the client needs and expectations. This involves conducting interviews, surveys, and workshops to gather detailed information about the desired functionality, features, and performance of the software. The next one is documentation. All the gathered requirements are meticulously documented in a formal document called a software requirement specification. This document serves as a blueprint for the entire document development process and ensures everyone involved has a clear understanding of the project goals. The next one is prioritization. Once all requirements are gathered, they are prioritized based on their importance and urgency. This helps ensure that the most critical features are developed first and less critical ones can be addressed later in the project. The next one is validation. To ensure the accuracy and completeness of the gathered requirements, they are reviewed and validated. Stakeholders, including the client, project team, and technical expert, validate it. This step helps identify any gaps, inconsistencies, and are ambiguous in the requirement before proceeding to the next phase. In this slide, we'll see about the design. System architecture. The system architecture defines the overall structure and organization of the software system. This includes the components, modules, and their interconnections, as well as the data flow and communication protocols. User interface design. The user interface design focuses on creating a intuitive and user-friendly experience for the software users. This involves designing the layout, navigation, and the visual elements of the interface, ensuring it is easy to understand and use. The next one is database design. If the software requires data storage, or a robust database design is crucial. This involves defining the data structures, relationships, and constraints that ensure data integrity, security, and efficient retrieval. In this slide, we will support implementation. Coding. Developers write the code based on the approved design specifications. They follow the chosen programming language, coding standards, and best practices to ensure maintainability and efficiency. Unit testing. Individual units of code are tested to ensure they function as expected. This involves writing test cases to verify the functionality of each code component in isolation. The next one is integration testing. Integrated components are tested to ensure they interact seamlessly with each other. This phase focuses on verifying the communication and the data exchange between different parts of the software. Next one is system trading. The entire software system is tested as a whole to ensure it meets the specified requirements. This includes testing the functionality, performance, and security and usability of the system. In this phase, we will discuss about testing. Unit testing. Individual models and components of the software are tested in isolation to ensure they function as expected. This is typically performed by the developers who wrote the code. The next one is integration testing. Once unit testing is complete, different modules are integrated and tested together to ensure they interact correctly and exchange data seamlessly. The next one is system testing. This involves testing the entire software system as a whole to verify it meets specified requirements. This includes testing functionality, performance, security, and usability. The next one is acceptance testing. The final stage of testing involves the client or user to verify that the software meets the expectations and is ready for deployment. In this lab, we will see about deployment. Server installation. The software is installed on the designated server or servers, ensuring it is configured and optimized for the target environment. Next one is network configuration. The software is integrated into the existing network infrastructure, ensuring it can communicate with other systems and users. The next one is user access. User accounts are created and permissions are given, authorized to user to use the software. In this slide, we'll see about maintenance. Bug fixes. Ongoing maintenance involves addressing any bugs or defects that are discovered after deployment. This includes identifying the root cause of the issue, fixing the code, and deploying a patch or update. The next one is enhancement. Maintenance may also include implementing enhancements or new features based on user feedback or evolving business requirements. This ensures the software remains relevant and competitive. The next one is security patches. To protect against vulnerabilities and cyber threats, security patches are regularly released to address known security flaws or vulnerabilities in the software. The next one is platform updates. As operating systems database or other user platforms are updated, the software may need to adapt to maintain compatibility and functionality. Advantages of the waterfall model. The first one is simplicity. The waterfall model is straightforward and easy to understand, making it suitable for projects with well-defined requirements. The next one is documentation. The model emphasizes thorough documentation at each phase, ensuring a clear record of the development process. Structure. The sequential nature provides a structure and disciplined approach to development, promoting a predictable workflow. The next one is management. They clear milestones and deliverables to manage and track the process throughout the project. In this slide, we will see about the limitations of waterfall model. Rigid. The waterfall model is inflexible and does not easily accommodate changes in requirements or unforeseen circumstances. Once a phase is completed, it is difficult to go back and make changes, which can lead to delays and rework. Limited user feedback. The model relies on upfront requirements gathering and does not allow for ongoing user feedback throughout the development process. This can result in a product that does not meet user needs. Late testing. Testing is conducted only after the software is implemented, which can lead to the discovery of significant defects late in the project, requiring costly rework and delays. Not suitable for complex projects. The waterfall model is best suited for small and well-defined projects. For a complex project with requirements and uncertain outcomes, more iterative and agile methodologies can be preferred. Thank you.